So the next topic we'll cover is feeds and speeds in terms of defining and reusing feeds and speeds based on operations. Now, after you install the system and you start using the system, essentially you can create your own default knowledge base for feeds and speeds and other parameters that are associated with operations. So that when new operation is created, the feeds and speeds and the other parameters that you saved as a default for that particular operation will be loaded from the knowledge base. Uday will walk you through an example of this, but for example, if you were to take the profiling operation and you were to go ahead and set and define your feeds and speeds and the other parameters associated with that operation, and you save that as the default, the system will then use that as the default the next time you use that same operation. And Uday will walk you through this as well. Now, you can also create a custom knowledge base where you can take a set of operations and load those to a knowledge base. So these are operations that you would commonly be using, and you define these operations once, you define the parameters, including the feeds and speeds, and you store it in a knowledge base. And you can then reuse this knowledge base in your next project, and all the operations and the parameters and the feeds and speeds that were archived will now be available to you. So once again, this saves you a significant amount of time in being able to define, archive, and reuse. And Uday will walk you through some examples now.
Just to make clear, I just want to make this point, Krish, that what we are describing here are different ways of skinning the cat, I guess, if you will. So there's not a single way that you can customize your feeds and speeds for particular operations. So I just wanted to make that clear. We're not showing something that's sequential. It's just different ways. You may choose to use a tool library for saving feeds and speeds and then loading it to the operations. That might be your preference. Or you could use knowledge bases for saving your feeds and speeds. So different ways of doing the same thing. It really is up to you. Thank you, Krish.
Thank you, Joe.
How we'll be able to use the default knowledge base to save the feeds and speeds. So those settings can be automatically be reused in addition to other parameters that are loaded from the default knowledge base. Now, as you can see on this particular example here, we have a profiling.
I'm sorry to break in. I think we lost the first part of your whatever you're saying. So just if you can repeat what you were saying, that'll be good.
Okay, sure, will do. So as Krish pointed out in the slide, where we're going to take advantage of how we could save the parameters, feeds and speeds and other cut parameters to a default knowledge base and reutilize the default knowledge base on new operations that you'd be programming on other parts, and we're going to demonstrate that in here. So what we currently have is we have a profiling operation program. You may have noticed this, how we program this profiling operation during we were demonstrating during one of the earlier topics. So I have established the feeds and speeds for this based on the tool. So I used one of the techniques to load from tool to load the feeds and speeds that was defined for this half-an-inch end mill. And we've generated a profiling operation in here. Now, once this operation has been generated, I could save the operation parameters, including the feeds and speeds parameter and any additional parameters that you may have set. Here I have it set to direction as climb, determine the cut side using a 3D model. I may have some additional parameters specified like arc fitting and maybe even sorting when adding multiple profiles. All of these parameters I've set can be saved to a default knowledge base, a default. So you can right-click on the operation and you could choose Save as Defaults. So when you select Save as Defaults, it'll prompt you with a dialog to save this under the defaults folder. I'm going to give it a name and then hit Save. You can choose the defaults folder or you can pick a folder of your choice. So once you save this to a defaults file, it'll automatically notify you that the operation is saved to a default. And the next time you program a new operation of the same type, in this case it happens to be a profile, you will notice that the parameters, including the feeds and speeds, are being loaded from the defaults that you had saved, so you don't have to go through the process of reestablishing your feeds and speeds. Now, in addition to the feeds and speeds, all the other parameters are also being loaded from the defaults. Now, these could include your cutting parameters, where we had already the cut direction set, your cut start side set, even your depths, like where you specify the cut levels, your entry and exit parameters, advanced cutting parameters. So all of these are being loaded from the defaults. Now, you can have a default setting for each and every operation type. So for example, if I have to program a hole machining operation in here, so I could do a drill operation, I can select all of the holes on this flat face. I can pick a drill tool. I can specify the feeds and speeds here to be loaded from the tool, establish the other parameters, the type of drilling, the depth, drill depth. All of these parameters can be set, and I can generate the toolpath and go back and save it to the same defaults. So when I click Save as Defaults, the defaults knowledge base will now have the default settings for both these operation types. So when you are programming another drilling operation on the same file or on any other part, by selecting the drill operation from the machining operations menu in here, you will notice that the feeds and speed settings are being loaded automatically from the defaults. And all of your other, in addition to all of the other cut parameters, as you notice here, these options are automatically selected, so you don't have to go through the process of resetting each of these parameters, which is a very nice productivity feature, and it saves you significant amount of time having to go back and reset the same parameters over and over again on each of the parts you're programming. Now, you might be wondering, where are these settings saved for the defaults? So if you go back into CAM preferences and you go over to machining, you will notice that under the group called default parameters, it's set to use the default knowledge base. So it's set to use the default knowledge base one we create. So it automatically assigns the last created default knowledge base to load. Now, you can have one or more default knowledge bases defined. Now, this could be defined based on the type of materials you're working with, or maybe it could be, you could classify them based on different categories. Could be based on the type of machines you're using. If you have one or more machines, you can have a default settings for each machine. Now, to switch back to the system default settings, you just click on the pull-down menu in here and go back and change it to undefined. And as you create a new operation and right-click and select Save as Defaults, you'll be prompted to specify a name. So before programming a new machining operation, you can choose which default knowledge base to use by going into CAM Preferences and Machining, and you can make the selection in here for the default knowledge base to use. So this is how we can establish a default knowledge base, and by creating a default knowledge base, your feeds and speeds and all the other cut parameters would be automatically loaded from the default knowledge base when you program a new operation by selecting the operation from the machining methods and the group called machining operations. Now, there's one other topic Krish covered in the slide where we can create your own knowledge base of operations. So the creating a knowledge base of operations where is like archiving your workflow or entire sequence of operations to a knowledge base. And this can be done by going into the Program tab. You would go to the group called Knowledge Bases and select Save to KB, or Save to KB represents saving to a knowledge base. I'm going to select Save to KB. I can specify a location where I want to save it. You could be saving it under your data folder, or you could be saving it in any folder of your choice, and I'm going to select Save. Now, as I start programming a new operation or a new part, I could simply load the knowledge base by going into the knowledge bases group under machining operations and choose Load Knowledge Base and select the knowledge base, and this will automatically load the operations that you had created in the knowledge base and saved it, and it includes all of the parameters, including the feeds and speeds that you had defined in the operation. So you could have one or more profiling operations, and each profiling operation could be using different sets of feeds and speeds, could be using different set of tools, different set of parameters. So as you save and load them from a knowledge base, each of those operations that are loaded in a knowledge base will have the parameters that you had saved. So this allows you to reuse those operations and reuse those feeds and speeds without having to go back and manually edit them and modify them. Now, if you need to change any of the parameters, you can always override it by going to any of these tabs. In this particular case, it happens to be feeds and speeds, as this is the topic we are focusing on today's webinar. So if you need to modify your spindle speed or any of these, you're always, you have the ability to change it or modify it. So we talked about two things in here. One is a default knowledge base, and we also talked about how we could save these operations, one or more operations that you've created, into a knowledge base, which you can archive it and then reuse those knowledge base on other operations. And I'm going to go ahead and hand this back to Chris so he can cover a few more topics for you.
Thank you, Uday. So the next topic we'll cover is how feeds and speeds are calculated. So this is the feeds and speeds calculator that's available in our system. In order to calculate feeds and speeds, there are a couple of things that are taken into consideration. The first is data from a table. And Uday mentioned this a little earlier when we were walking through some of the menus, and you saw load from file. And this is what the data from table is all about, and Uday will go into some more details. But the data from table essentially, based on the stock material and the tool material, feeds and speeds are calculated. And this information is stored in an external file, and Uday will show you where the external file is stored and how you can add your own materials to the tool. But this first piece of information to calculate feeds and speeds comes from this external file. The second set of parameters that need to be used for calculating feeds and speeds are the input variables in terms of the tool diameter and the number of flutes. And Uday walked through this as well when we were first talking about defining and creating your own tool library, and he'll cover that in a little bit more detail. So based on the tool diameter and the number of flutes, the system then uses all of these parameters combined to calculate a spindle speed, which is measured in RPM, and a cut feed, which is based on the units you're working in, whether it's inches or millimeters. So just to summarize this slide before Uday gets into the demonstration is, in order to calculate the feeds and speeds, we use the data from table, which is the materials file, and we use the input variables, which are the tool diameter and the number of flutes, and we therefore are able to create compute a spindle speed and a cut feed. Go ahead, Uday.